have to just try to decide which side to box in. Neither one is obviously nice, but you'll notice the right hand side, we have things multiplied, we have cosines. Usually it's easier to turn things into sines and cosines than it is to take sines and cosines and turn them into something else. So I'm going to box in this side. There's not a right or wrong way. Sometimes there's an easier way, but if you did it using the other one, it doesn't mean you're wrong. What could I change tangent squared to? After a little flip chart, tangent, sine over cosine. What would we do with secant? How do you divide fractions? So the first one stays the same, times, and you flip the second one. Then the cosine squareds drop, and all we're left with is sine squared. All right, look at your box. Look at where we're going. I need cosines. All I have is a sine. Is there anything I could change sine squared to? If you're stuck, it is acceptable if you get to a point and you have no idea where else to go, it is acceptable to work the other side and see if we can turn it into the same thing. So one other strategy, if you try this and you can't get it to work, I'm going to erase my box here. I turned the left side into sine squared, so now I'm going to see if I can turn the right side into the same thing. Make sure your work is easy for me to follow so I can clearly see this is where I'm working the left side, I'm going to work the right side over here. And now I switched my box to a sine squared, I'm going to try to get a sine squared on this side. What could I do with these two parentheses? FOIL. So we get 1 minus cosine s plus cosine s minus cosine squared. The cosines drop. I have 1 minus cosine squared. What is that? And so I got it. So a new strategy, if you're working these and you can't figure out how to get to the other side, you can stop, work the other side and see if you can get them to the same point. But your work has to be clear. I have to see that you're working both sides, that I simplified each side to the same point.
Could we have continued sine?
Yep, you could have changed sine squared to 1 minus cosine squared from the formula, and then use difference of squares, so that would factor into 1 plus cosine and 1 minus cosine. So we could have got there, we just didn't come up with it, so we tried something different. Let's try another one.
So now we're factoring both sides.
Only if you get stuck.
Okay.
So my strategy is still going to always be to box in one side and try to work to that, but if you get stuck, you can try working both. All right. Which side would you prefer to box in here?
Right.
Right, yeah, that's probably a little bit nicer. We don't have all the fractions. Okay, the left, what do you want to do? All right, so what would I change tangent to? These are the formulas that you are expected to know, so if you're struggling with these, you might start studying them now. Cotangent is cosine over sine. The bottom is already sines and cosines. Okay, you could think of the bottom as being over 1. Then to divide fractions, we flip and multiply. So I'm not touching the top. Times, I'm going to flip the bottom and make it 1 over sine t cosine t. Now I have to distribute. If you multiply this first one, what do we get? Because we had sine t times 1 and cosine t times sine t cosine t. Okay, minus the other one. Cosine t times 1 is cosine t. Sine times sine cosine would be a sine squared cosine. What happens now? We could get a common denominator, but let's reduce these fractions first. Look at where we're going. We basically want two things subtracted. We don't want one big thing. But if you have a sign on top and bottom, it can cancel. So we have 1 over cosine squared minus, that one, the cosines drop, 1 over sine squared. What is 1 over cosine squared t? Reciprocal of cosine is? What is 1 over sine squared t? So that one, we didn't get stuck, so we never had to go work the other side. And we only do that if we need to. Questions there? I'd like to do at least 2 more, and then I want to make sure we have plenty of time to work today so you guys can ask questions. I'm going to do this one. So we have cosine x over 1 minus sine x equals 1 plus sine x over cosine. All right. Any ideas here? Does one side look obviously easier than the other?
One side looks like you can do something with it.
So you want to box in the left then?
I mean, I think we could do something with the left
Oh,
side.
okay. So box in the right. Okay. These are pretty similar in that they both have sine and cosine in them. But we don't have like sine squared or cosine squared that we have an identity for. So, the final new strategy I want to suggest to you. You notice I want just a plain cosine, but this one needs a 1 plus sine x in here, doesn't it? if you don't have anywhere else to go, I can't change the sines and cosines because I'm already there. I can't break this fraction apart because there's more than one term on the bottom. It is legal to multiply the top and bottom by the same thing. Just like with getting a common denominator. If you multiply it on top and bottom, that's okay. Look at what I want. In the one I'm trying to get, I need a 1 plus sine x. So I am just going to introduce that into my problem. I am going to multiply by 1 plus sine x on top and bottom. There was no other way I was going to get there, no formulas. I'm already in terms of sine and cosine. Now, I am not going to distribute it out on the top because if you think about your goal, you want the top to just be a 1 plus sine x. So what I'm really hoping is that cosine will go away eventually. On the bottom, if I FOIL that out, I get 1 plus sine x and minus sine x drop, minus sine squared x.
It's just cosine squared.
1 minus sine squared is cosine squared x. Then what happens?
Cosines cancel out.
We cancel 1 cosine. So we have 1 plus sine x over a cosine x.
So how come we weren't supposed to just randomly just put numbers into a problem?
As long as you aren't changing the original. So essentially you can multiply by 1 because that doesn't change anything. If you do it on top and bottom, they cancel each other out, so you're still just multiplying by 1. So you haven't changed your problem.
Okay.
Now you couldn't just add it on only the top or only the bottom. You have to do both if you're going to put it in there.
Alright.
Other questions? Let's do another one together. Alright. Which one do you want to work with?
Right side.
Work with the right side? Okay, so box in the left. Alright. What do you notice about the top?
Cofactor.
Yeah, we could do box method. Cosine squared breaks into cosine. What multiplies to positive 1 and adds to negative 2?
Negative 1.
What can I change sine squared to? Okay. If you wanted, you could distribute that negative. It would give you a negative 1 plus a cosine squared. So that's like cosine squared minus 1. What can I do with that?
Cancel.
Well, we have to factor it first. Cosine squared minus 1 is the difference of squares. So it breaks into cosine theta plus 1, cosine theta minus 1. So I distributed that negative, so then it was cosine squared minus 1. So that's difference of squares. Then what happens? Yep. The whole reason we factor is to cancel things out. So I get cosine theta minus 1 over cosine theta plus 1. Okay. We're really just one step from the answer. Does anyone see how to get there? No? So if you're stuck, what do you do? Yep. So we said, okay, I worked here, I can't figure it out. So instead, that's my new goal. I'm going to try to turn the other side into the same thing. What would we change cotangent to? Cosecant. Over cotangent, which is cosine over sine, minus cosecant is 1 over sine. Oh, that's a plus. Sorry. Couple options for what we can do here. What do you guys think?
Common denominator.
Okay, we can work with common denominator. They both already have it. So that's cosine theta minus 1 over sine theta over cosine theta plus 1.
Couldn't you just change cosine over sine to cotangent?
Yes, but that's where we were to start with. Because we started out, we got stuck, and so we're trying to work with that one now. So at this point, you can either flip and multiply or use the strategy we said if you multiply the top and bottom by the same thing, that's also legal, so I don't care. If you just want to recognize if you can multiply top and bottom by sine theta, both of those denominators cancel. Same thing you would get if you flipped and multiplied. So you get cosine theta minus 1 over cosine theta plus 1.
How would we have continued the right side? Just,
You could take top and bottom times 1 over sine.
I was just thinking sine, I didn't think 1 over sine.
Yeah, if you want to get a sine in the denominator for each of those, then you would have had cosine over sine minus 1 over sine, and then that would have turned into your cotangent
Okay.
minus
I
cosecant.
wasn't too far off on that.
Nope, you weren't. Alright, other questions? Alright, what I want to do is just give you guys some time to work and ask questions. We are continuing with this stuff on Monday, so we're just doing a little more each day to help practice. It might be beneficial if you want to work with somebody today, you're welcome to do that. I'll be coming around and answering questions, but if you want to pair up, that helps too. I think I gave you 8 problems last night.